of operations on complex numbers. Okay, so first let's discuss what is the meaning of z1 plus z2. Okay, as in the case of vectors we studied, if we add two vectors, how do we add two vectors? By the triangle law or by the parallelogram law. So if this is my first complex number z1, x1 comma y1, and this is the second complex number x2 comma y2, so the resulting complex number will be x1 plus x2 plus iota y1 plus y2, and that can easily be plotted by the parallelogram law. So the resulting complex number will be somewhere over here, and this is equal to z1 plus z2. Similarly, if we want to plot z1 minus z2, what will we do is, suppose this is z1, x1 comma y1, and z2 is x2 comma y2. What we can do is, we can simply see what will be the value of minus z2 and apply parallelogram law over here. So the value of z1 minus z2 can be plotted in the fourth quadrant, something like this. Okay, so the next thing is, equation of circle in case of complex numbers. So what is the locus of circle? That circle is the locus of all the points which are equidistant or which are at a constant distance from a fixed point. Okay, in case of complex numbers, let's say this is a fixed point z1 and the constant distance is equal to r. Okay, and we have to find the locus of this complex number z. So we can easily say that if the locus of z is a circle, then the distance between z and z1 is always equal to r. Okay, so this point z1 will denote the center of the circle, and this scalar will denote the radius of the circle. Okay, so if, for example, I want to plot this expression on the complex plane, so what does it denote? It denotes a circle, and the center of the circle will be 3, 4, and the radius of the circle will be 3. How? Because it says that our complex number is such that its distance from the point 3, 4 is always equal to 3. So the circle will be somewhat like this. Okay. Similarly, next case can be z minus z1 mod is equal to z minus z2 mod. What will happen in this case? This denotes that the distance of the complex numbers from two fixed points z1 and z2 is same. Okay, the distance of the complex number from 2 points z1 and z2. Okay, this distance is a, this distance is a, b. So our complex number p is such that its distance from these 2 points is constant. Now first case can be if this complex number is the midpoint of these two complex numbers. Okay, or this can be anywhere over here such that these two distances are same. So what is the locus of the point which is equidistant from two fixed points? It will be a perpendicular bisector. Okay, it will be the perpendicular bisector of the line segment joining these 2 points, these two complex numbers. Okay, so this will represent perpendicular bisector of line joining z1 and z2. Okay, similarly, if I have to find the midpoint of two complex numbers Z1 and Z2. The midpoint will be equal to Z1 plus Z2 upon 2 by simply applying the midpoint theorem in complex numbers. Okay, so this is all about the geometrical interpretation of the operations on complex numbers.